foiling. So we did some practice with that yesterday, but we'll use this kind of as our warm-up for today. So foiling, if I wanted to multiply, I'm going to multiply these two together, so I end up with x squared. Do the outside, so that's plus a 2x. The inside, that's plus 4x. And then the last would be plus 8. I can combine these like terms, so this would be x squared plus 6x plus 8. All right, so that's just a quick warm-up of how we can how we can multiply product of two binomials together. Now we're going to go the other way. So I have on here, what is factoring? So factoring, you can think of it as unfoiling, okay, breaking it up, breaking standard form into a product of two binomials. All right, it's simply kind of breaking it down into another form that is still an equivalent form. All right, we're not changing it at all. Okay, and here officially rewriting an expression as a product of its factors is what that says. Sorry, I forgot that piece came up, or else I wouldn't have written over it. So this is what I had. Erase that so it doesn't look so jumbled in there. There we go. Okay, what we are going to do is factor quadratic trinomials. So quadratic, remember, is anything that's squared. The squared is my highest power that I'm going to have in my expression. Trinomial, that tri means 3, so this is a 3-term polynomial. From standard form into two binomials. And again, binomial, this means 2-term polynomial. All right, 3-term, we had like that ax squared plus bx plus c. That's a quadratic trinomial. A 2-term polynomial would be like x plus 1. So it's 2 terms. X and 1 are each of my terms. Okay. All right, let's get actually into one. So if I asked you to factor x squared plus 6x plus 8. Now, this is something that you did in Algebra 1, but that was a long time ago for some of you. Okay, so I might do it a little bit different than another teacher that you might have had for Algebra 1, but it's all coming to the same ending point. So what I do what's called the cross method into 4 spots. And so I literally make a cross on my paper whenever I'm doing factoring. So the first thing is I draw my cross. The top of my cross, I'm going to do a times c, because remember, this is in standard form, ax squared plus bx plus c. And a and c are numbers. So I'm going to do a times c. So in this case, it's 1 times 8, which is 8, so I'll put an 8 on the top. And then my bottom is always my b term. So in this case, it's 6. So I want to think of 2 numbers that multiply to get 8, but also add to be 6. So I'm trying to think of 2 numbers I can multiply to get 8, but when I add them up, I get 6. What two numbers would this be, Evan? Positive 2 and positive 4. Okay? You could write it in your cross as 4 and then 2, or 2 and the 4, it doesn't matter. Now, I am going to take those values and I'm going to create 4 spots. My first spot, I simply bring down that first term x squared. My next 2 spots are breaking apart the 6x. And I'm breaking apart the 6x to use my new 2 numbers that I found. So now this becomes 2x and this becomes 4x. And then my last spot is simply going to be 8. And then I want to keep the signs with all of these. These were all positive, so I'm going to have addition between each one. All right, so this is still equivalent, because if I gave you this here in purple, and I said, well, simplify, you would combine these like terms and you'd get 6 right back. So it's equivalent. So I've created my 4 spots. Now I actually want to do some grouping to factor. So I'm going to group these 2 and I'm going to group these 2. I'm going to group the first 2 in my 4 spot and then the second 2 in my 4 spot. Now I want to factor out GCF of each. In GCF, this means greatest common factor. So x squared plus 2x, x squared really means x times x. So I have x times x plus 2x. The only common factor in this first set of parentheses is an x. I have x times x and I have 2 times x. So I can factor out an x, and so I end up with just x times x plus 2. Now my second grouping in parentheses has to have this x plus 2 again. It has to be the same thing as a common factor. But now I'm trying to figure out what factored out gets me back to be 4x. So on this one, I could bring a 4 with it, because 4 times x is 4x. And then I can check it 4 times 2. Yep, that does still equal 8. So I'm still equivalent. And these are being added because they're still positive. Now I see this common factor of x plus 2 on each of these. This x plus 2 is the same. And it's being multiplied by x in the first term and multiplied by 4 in the second term. So I'm going to say x plus 2 is my common factor. In this first grouping, I had x plus 2 times x. So that's equivalent, x plus 2 times x. But then in my second group, I have x plus 2 times 4. And so I can also have a positive 4. So this is my factored form, x plus 2, x plus 4. Now, I'm going to put a little star here. You may have noticed that it's the exact same thing as what we had in our cross. We had 2 and 4. And so I could have jumped to x plus 2 and x plus 4 and been done. But this only works, all in caps, when your a value is equal to 1. So I kind of showed you the long way to do it that will work for any factorable quadratic that you have. I showed you the long way that work every single time. But if you recognize right away that your a value is 1, right here from your cross, you can immediately jump and say, well, it's a positive 2 and a positive 4, so it's going to be x plus 2, it's going to be x plus 4. Okay? But be very careful with that. Make sure your a value is 1. If it's not, if that was like 5x squared, you have to do it the long way. You can't do it the shortcut way. All right, let's do another one for practice. So now I have x squared plus 9x plus 20. All right, first thing I'm looking at is I see that it's a 1x squared. So I can use my shortcut method. But I'm still trying to think of two numbers that will multiply to get 20 that will add up to be 9. Jacob Boone, you think of two numbers multiplied to get 5 and 4. Now, because my a was 1, I can just say x plus 5, x plus 4, and I'm done. Okay. If your a value is negative, so this one's a little bit different. So if we have a negative x squared, no problem. We just got to adjust this right here from the beginning. I want to factor out that negative 1, the negative essentially. So if I factor that out, I will have a negative times x squared. But then this becomes a negative 13x because negative 1 times a negative 13 gets me back to my positive 13. So I don't want to change my problem at all. I'm just changing how I'm writing it. My negative 12 now becomes a positive 12. All right, and you can check this. If I were to distribute this negative in, if I thought it was negative 1 times x squared is negative x squared. Negative 1 times negative 13 is positive. Negative times a positive is negative. So all we've done was bring out that negative value. We're just going to set that off to the side. We're not going to worry about it till the very end. Now all I have to do is factor what I have in here. Okay, I've factored that negative out. I'm not going to worry about it. It's just setting off to the side. I'm going to focus just what's on inside my parentheses. All right, so I want to come up with two numbers multiply to get 12 that add up to be a negative 13. Chris, what do you say? Okay, so negative 13 and 1 don't multiply to get 12. So the top is multiplication. Yep, so multiply to equal 12, but add to equal negative 13. There you go, negative 12, negative 1. So again, we're only factoring what's in our parentheses, and inside our parentheses, it was 1x squared. So we can jump to say x minus 12 times x minus 1. But then again, do not forget to bring this negative along. That negative did not disappear, it's coming with us. But in terms of our calculations, we don't have to worry about that negative. So this is our final answer. Negative of x minus 12 times x minus 1. And as simple as it sounds, that is so often forgotten about, that negative, that you do it from the start and then you don't bring it back in at the end. Okay, so make sure that carries through in the problem. It's not applying to any recalculation steps, but it's coming along for the ride. Okay, greatest common factor. So the greatest common factor of the terms, greatest simply means that greatest coefficient of the greatest, that should be of the greatest exponent. Or no, it should be and, sorry. And the greatest exponent. Because we could have, if we have x squared in all of our terms, we can bring out an x squared. If I have all even numbers, I could bring out a 2 at the very least. I might be able to bring out a bigger number. So that is an and statement. And whenever you're looking to factor a quadratic, you're always looking to see if there is a greatest common factor that you can pull out. Especially as your quadratics get more and more involved. If you can bring out a greatest common factor from the start, it'll make your factoring a lot easier. Okay, so if I had a quadratic that looked like 4x squared plus 20x minus 56. So if I was thinking of this, okay, I'm trying to come up with two numbers that will add up to be 20. Negative 56 times 4, that'd be a negative 112. 224. Ugh, I don't know my factors of negative 224, and it gets pretty involved. Okay? Fortunately, we might not have to do that. Let's see if we have a greatest common factor. So start with your smallest one. So I know my factors of 4, I could only have 4 times 1, and I can only have 2 times 2. All right, let's go to factors of 20, and let's see if I could do my greatest common factor is either a 4 or a 2. Well, yeah, I know I could do 4 times 5 on 20. So far, 4 is my greatest common factor. Let's check it with 56. And I'm not worried if it's positive or negative right now. Is there 4 times a number that'll get me 56? What number, Evan? What is it? 14. Okay. So I know 4 times 14 will get me 56. So this 4 is the greatest common factor of all 3 terms. That means I can factor a 4 out, and this simply becomes x squared plus 5x minus 14. And you can always check it, okay? If I distribute in, yep, I get 4x squared. Yep, I get 20x. Yep, I get negative 56. Okay? Now, this 4 is just coming along for the ride. Just like that negative was coming along for the ride on the last one, this 4 is coming along. And so do not forget about it, but it's just coming. It's not going to be applied to any of the multiplication. It's just coming along with us. So all we have to do is factor what's in my parentheses here. So now I have a negative 14 that adds up to be 5. That's a little bit easier one to factor. So 2 numbers that will multiply to get negative 14 that will add up to be 5. Reese, can you think of 2 numbers? So let's just think of factors of 14. I know I can do 1 and 14. Can I do 2 and anything? I can do 2 and 7. I can't do 3. I can't do 4. I can't do 5. I can't do 6. All right, I'm limited here. So I'm going to try to work with these numbers, okay? 1 and 14, I can't make 5. But 2 and a 7, really when I wanted this to be negative 14, I can think of 7 and negative 2 would give me my 5. So this is 7 and negative 2. And again, my coefficient on x squared was just 1, so I can immediately jump to say x plus 7, x minus 2. I still have my 4 out front, and I'm done. Every time you look at a quadratic, look to see if you can factor out a greatest common factor. Okay? It's really only going to happen when your A value is not 1. But always look to see if you can factor out a greatest common factor, because then it'll make things a lot easier for you. Okay, that should be the first thing you should come to your mind. Okay, that's it. So page 221, some textbook problems, but also a couple of IXLs. First one's only to 40, and this means the Algebra 1 tab, this A1, this means the Algebra 1 tab. So make sure you're in the Algebra 1 tab. So Algebra 1, AA.2, and then also Algebra 1, AA.4. So it goes A through Z, then it starts doing AA, BB, CC, DD. So this is AA.2 and AA.4. So work on these, and then once you are done with the textbook problems, you can do the IXL, or vice versa if you want to do the IXL.